there are few messages which OSPF is exchanging. First of all, it is the hello packet, and the hello packet is more like a discovery mechanism, and it is used to establish OSPF neighborhood, and it is sent as multicast to 224.0.0.5 address, and this multicast address is representing all OSPF routers, and any router that is configured with OSPF will listen to this address. Here we have hello packet and what it contains. So the area with orange is the OSPF header, and it will be the same for all OSPF messages, and the green area is representing the field which are characterized by a hello packet. We have version, we can have version 2 and 3, we can have type, the length of the packet, we'll have the router ID, the area ID. If we have authentication, this marker here will describe the authentication type, and this field is for the authentication. What we are interested is the hello packet. It will contain the network mask, and if two routers are exchanging hello messages, the network mask should match between one segment, or between the interface that is connected to router A, which is connecting to router B. They must have the same network mask. Also, we'll have the hello interval, which by default is 10, and it is used as a keep alive mechanism, and this must match on the routers which are participating in OSPF. We also have dead interval, which is usually 3 times the hello interval, and it is also a part of the keep alive mechanism. If this interval expires, a neighbor will be declared down, and again it must match on both routers. We also have options. Options are used to signal special area type like stub, NSSA, totally stub area, and totally not so stubby area, and it must match between neighbors. Also, we have priority, which describes the router priority. Default is 128, and it can be from 1 to 255. We also have a field which is describing the designated router, and a field which is describing the backup designated router, and it will also list all available neighbors on the broadcast medium, meaning on this multicast IP addresses. We can also have a database description, which is also a SPF message, and it is used only during the neighbor formation process, and it serves two purposes: to determine who will be in charge of the database synchronization by electing a master and a slave router, and the master will set and maintain sequence number for the database description transfer process. I will explain in other slides how all of this works. Also, database description messages will expire after all neighbors exchange the DBD packets, and the master and slave relation will be forgotten, and it will not be used further. Okay, and we also have our OSPF header and our database description specific messages. So for database description, we have the MTU. MTU in the interfaces must match. We have the options field, which describes various router capabilities. We have this field here, which is always 50, and it is fixed. We also have the I field, which is called the initial bit, and if this field is have value of 1, it will signal the initial DPD packet, and only the first packet will have this I bit set to 1. The rest will have a value of 0. M is the more bit, indicates that the database description transfer is not complete when it is set to 1, and when it is set to 0, it means that the router is receiving the last database description packet. We also have the master slave. When this bit is set to 1, it means that the router is master. When it is set to 0, it means that it is slave. Also, we'll have the sequence number, and it will increment when the data will be sent. Each packet will have his specific sequence number. And we also have the LSA headers, which will list all of LSAs in the linkstat database of a given router. Okay, we also have the link state request message. This is doing the following. When the database description packets are being exchanged, the router will analyze the received database description packets, and in case that a router will receive an LSA header that is not in the database description, it will send a link state request message. So LSR is basically a request for the missing information. The LSR portion of the OSPF packet is pretty simple. We can have the link state type, which is identifying the link state type. We can have the router LSA, network LSA, summary LSA, autonomous system border router summary, autonomous system external LSA, and not so stabby array external LSA. And we can have the link state ID, which identifies the network link between OSPF router. It is usually an IP address. And we'll have the advertising router, which is the IP address of the router which is sending the link state request packet. As a response to link state request message, we have the link state update, and this is providing the information requested by LSR. It will be generated in case also that there are changes in the network, like new neighbor, link failure, a router that is down, and so on. Any change in the OSPF topology will trigger these messages. This message can be shared to all OSPF routers using 224.0.0.5 multicast address, or it can be shared to all designated routers, which means the designated router and backup designated router, and it will use 224.0.0.6 IP address. The LSR packet will include the number of link state advertisements, which is telling us the number of LSAs that are being sent, and we'll have the LSAs, which is the actual requested information, routes, and so on. Also, we have the link state acknowledgement, and this whole process, like link state request, link state update, and link state acknowledgement, it works like in TCP. A link state acknowledgement is a confirmation that the data has been received, and this message contains nothing else than transmitted LSA headers in the update message, each header being acknowledged individually. So guys, most of you are viewing my videos and are not subscribed. So if you want to help me and if you like the videos that I am creating, please hit that subscribe button. It will help me a lot. Thank you. Thank you. Now you know more, and if you want to learn even more, you can check my linked Udemy courses in the video description. Also, on each Udemy course, you can find a 30% off coupon, which is listed in bonus section of each course. You will find them listed in the video description. Thank you, and see you in the next video.